Le Chateliers principle is incredibly useful for us to predict what happens to equilibrium when we chart altering conditions. At A2, we're going to put some numbers on it and we'll explain why it works. At AS, we kind of just think, yay, this works for us, let's go with it. But you have to remember, you have to learn what the actual principle is. So he says, when a system which is in dynamic equilibrium is subjected to a change in conditions, the equilibrium will shift in the direction to minimize the change. Okay, that's his principle you've got to learn. So often they'll say, at the beginning of these questions, for 2 marks, what is Le Chateliers principle? And people try to explain it using their own words and get so confuddled it goes horribly wrong. So just make sure you can nail it with that definition. We'll do concentration. And what we're going to do is we're going to use Le Chateliers principle with this equilibrium to try and predict what will happen. So, Le Chatelier said, if I do something, the equilibrium is going to shift, undo what I've done, basically. So, if I add in a chemical, the equilibrium will shift to try and remove the chemical. So, if we add in a reactant or product, the equilibrium will shift to remove it. So, e.g., what would happen if I add in more oxygen gas? I'm adding in more of that. The equilibrium will go, whoa, you've added more oxygen in. What does it want to do? It wants to... Yeah, it wants to remove it so it shifts to the right. Fabulous. So if you add in more O2, the equilibrium will shift to the right-hand side to remove the additional O2 gas. Okay. So concentration, quite straightforward. Pressure only works if they're gaseous reactions. So the key thing that I would do is I would add up how many moles of gas you have on each side. So how many moles of gas do I have on my left-hand side? 3. 3. Brilliant. 3 moles of gas. It's only gas that counts. How about on the right-hand side? 2 moles of gas. If I increase the pressure, the equilibrium will shift to reduce it. So if I increase pressure, the equilibrium will shift to decrease pressure. So in this example, if I increase pressure, which way will it shift? The more gaseous moles I have, the higher the pressure.
To the right.
Brilliant, it will shift to the right. So if I increase pressure, the equilibrium will shift to decrease the pressure. So shifts to the side with fewest gas moles. In this example, it shifts